Hello, welcome once again to my channel. Today we are now going to proceed with our previous lessons, and that is going to be differentiating trigonometrical functions using chain rule. I am very sure you've heard about chain rule before, but we could have used it to differentiate non-trigonometrical functions. For today, it will be basically differentiating trigonometrical functions. Now, we are going to find out something very unique today. Remember, we already differentiated sine x, we got cos x. Cos x, we got minus sine x, and many others. But today, I have unique trigonometrical functions here. The first one is sine 2x. We want to find out what will happen when we differentiate sine 2x. Will it also be 2 cos x? Will it also be cos 2x? Or not. We are going to establish that today and clear out the doubt that someone could be having. Then we shall also look at cos 3x. We shall find out whether it is simply going to be negative sine 3x or not. So by the end of this lesson, you should be able to know how to differentiate any trigonometrical functions using a shorter format or a shortcut. So let us begin with the very first function, and that is sine 2x, and we see what we actually obtain when we differentiate it. So now today what we're going to be interested so much in, especially in part A, is going to be the angle. The angle that you see here is 2x. So what I will do is, after letting y to be the whole of this function sine 2x, I will let also u to be the angle, which is 2x. I'll let you to be the angle, which is 2x, and this will automatically imply that now y becomes sine of u. Why have I said sine of u? Because I've called it 2x to be u. Now I'm going to differentiate each of these functions independently, then I apply the chain rule later. Now if u is equals to 2x, we can be sure that du dx will be 2. If u is 2x, then it means du dx is 2. Then if y is equals to sine u, then we can also be sure that dy du is cos of u. dy du is cos of u. Why have I said cos of u? It's because in the previous lesson we confirmed that when you differentiate sine x, you get cos of x. Now u simply replaces x, meaning when you also differentiate sine u, you get cos of u. Now that we are here, we shall say the chain rule states that dy dx, which we are looking for, is going to be dy du times du dx. dy du times du dx. Now the next step is going to be simply substituting. We are simply going to substitute for dy du, and we know dy du is cos u, then du dx is 2. So it means at the end of the day, we shall have 2 cos of u. But remember, we call the u to be 2x. So it means at the end of the day, we can conclude that dy dx is equals to 2 cos of 2x. Now what do you realize? You realize that when you differentiate sine 2x, you don't simply get cos 2x, but you get 2 cos 2x. What has happened is, we have differentiated the angle first, then we multiply the derivative of the angle by the derivative of our trigonometrical function. So that is what happens in that case. Let us move on to part B. Part B says cos of 3x. Now we shall again let y to be cos of 3x. Shall let y to be cos of 3x. Then again we put interest in the angle. So this will mean that we shall also let u to be the angle, which is 3x. What does that now imply? That now implies that y becomes cos of u, because u has now been called our 3x. Then we differentiate this function with respect to x, so it means I will have du dx giving me 3. When you differentiate 3x, you get 3. Then we also differentiate this function, but with respect to u. So I will get dy du is equals to, when you differentiate cos of x, remember, we said you get minus sine of x. Meaning when you also differentiate cos of u, you get minus sine of u. So I'll get minus sine of u. Now from chain rule, dy dx. So dy dx will be dy du times du dx. But we have our dy du as minus sine x. I have minus sine x. Minus sine u. And we have the u dx as 3. So when I multiply this by 3, this now becomes a minus 3 there. So I will get minus 3 sine of u as dy dx. But remember, our u was nicknamed earlier on to be 3x. So it means we shall conclude that dy dx is now going to be minus 3 but sine of 3x. So again, you realize that when you differentiate cos of 3x, you don't simply get minus sine of 3x, but you get minus 3 sine of 3x. Where does the minus 3, where does the 3 come about? The 3 comes from the derivative of the angle. So we are about to conclude that when you're differentiating any trigonometrical function, first differentiate the angle, then the derivative of the angle is multiplied by the derivative of the trigonometrical function. So this becomes our dy dx. Let us move on to part C. Now part C says tan of 4x. Tan of 4x, without wasting time, this time around I will simply let y to be the whole of that function, which is tan of 4x. And of course we shall let u to be the angle, which is 4x. I now say this will mean that now y is tan of u, as we said in the previous examples. So when I differentiate this first function, I will get du dx as 4. When I differentiate this second one, I will get dy du as 6 squared u. Remember, when you differentiate tan of u, you also get 6 squared of u, just like we did for tan x. Then from there we shall say dy dx from chain rule is equals to dy du times du dx. So the next step is substituting, which is going to give us 6 squared u, then times 4. That gives us 6 squared u. But remember, u is 4x, meaning now we shall have 6 squared of 4x. 6 squared of 4x, and that becomes our dy dx. As simple as that. Next is going to be part D. Now for part D, it is a little bit unique because we now have a square and our angle is simply x. But remember, from the first three trigonometrical functions we have differentiated, we realized that you first differentiate the angle, you get the derivative of the angle, then multiply by the derivative of the trigonometrical function. So this time round, I will write this as, I will say let y equal to sine of x, then the whole of this squared. I will keep the square to be out of the bracket so that it is an over of power. Then from this point, I will let you to be what is inside the bracket. This time round, I'm only not letting the angle to be u, but I'm calling the whole of this u because of this square here. So that now it implies that y is now going to be u but what? U but squared. It's going to be u but squared. And I differentiate this first function here. This will mean that du dx is going to be cos of x. When you differentiate sine of x, you get cos of x. Then when you come to this one here, dy du will be 2u when you differentiate it. Now by chain rule again, dy dx, which we are looking for, is going to be dy du times du dx. When you do the substitution, dy du becomes, we already had it as 2u, then du dx. Du dx, we got it as cos of x. But remember, our u is already sine x. So it means dy dx will now be the same as 2 sine x cos x. I will maintain the angle cos x. So that becomes our answer when you differentiate sine squared of x. Or someone could even proceed and modify this and write it as sine of 2x. And that is coming from what we call double angles. But it's not a must that you have to proceed to this. This is good enough, unless otherwise. Now let us do part E, and I think for part F, I will let you also try it out because we already know the concept of differentiating. You differentiate the angle, get its derivative, multiply by the derivative of the whole angle. I mean of the whole trigonometrical function. Remember, the angle will always be maintained. Now for this case, we are going to let y to be cos squared of 2x. But I can keep this square again out here. It is very much okay. Then I will let u to only be what is inside the bracket. That will be cos of 2x. So now this time around we need to be knowing how to differentiate cos 2x directly. And that is going to be differentiate the angle, you get 2. Then you multiply by the derivative of cos. When you differentiate cos, you get negative sign. So it will be minus 2 sine 2x. Okay. Now from this point, I will say, of course, if u is that, y will be equals to u but squared again. When I differentiate this, now du dx becomes, so I have this as du dx, and it will become minus 2 but sine of 2x. Then we also differentiate this function here. So we shall have dy du, and that will be 2u. When we bring in the chain rule, dy dx we are looking for will be dy du times du dx. And that comes to dy du, which is 2u, du dx, which is minus 2 sine 2x. So I'm going to have into minus 2 sine 2x. And if you simplify this, it comes to minus 4. But remember, my u is already given here as cos 2x. So I will say minus 4 cos 2x. Then sine 2x. If someone wants to modify this, you can break it down so that you have negative 2 into 2 cos 2x sine 2x, which is the same as sine 4x. So the answer will be minus 2 sine 4x. That would also be very much okay. But this is good enough. Now after reaching this point, now I expect you to try out part F, then also try for me the following questions. Okay, let us try out the following questions to make sure we get better and perfect on what we call differentiating trigonometrical functions using the chain rule. Next lesson, we shall now bring in the application of the product and the quotient rule. But you should have mastered this clearly because we shall basically use the shortcuts. We shall not be going through all these processes. Thank you very much. Remember to share this video, subscribe if you didn't, and make sure you encourage others out there to also do the same. Bye-bye.